is Miss Connolly. I've been making videos for my own students, and this one is for them. But I wanted to make them public so that I could reach as many of you as possible, so you could be prepared for the next grade. So if you have any questions that you need answered, connollymathathome@gmail.com. Parents, students, teachers, feel free to share this with anyone who you think would help, okay? So let's get started. If you are in my class, and if you're watching this video, I'm going to tell you which ones you should watch first. You have watched the video Introduction to Multiplying by Powers of 10. You watched Multiplying Decimals, Part 1. You've watched Multiplying Decimals, Part 2. And you've watched Multiplying Decimals when both factors are less than one whole. And I can see some of you saying this, why didn't you just tell us this at the beginning? I'm going to show you a way to know where the decimal goes every single time. It's another strategy, but I had to make sure you understood what was really going on. I can't just teach you a trick, okay? So, how do we know where the decimal is going to go every single time? Well, you're still going to use estimating. You're still going to be thinking about multiplying with whole numbers and then adjusting based on how much smaller a factor has gotten. You are still going to be thinking about if both factors are less than one whole, you can still think about multiplying like their fractions. You can still think about the area model. But I'm going to show you something else that you can think about, okay? So here we go. I'm just laughing because I know some of you are like, why didn't you just tell me? When we're thinking about 14 4/10 times 8, okay? I've taught you to think about making an estimation so we know where the decimal goes. So I'm going to do that real quick. I know that 14, if I was at 14 4/10, I would round down to 14 times 8. So 8 times 10 is 80. 8 times 4 is 32. So 80 plus 32 is 112. So that's my estimate, and I know that my decimal should go somewhere to make my product closer to 112, okay? The other thing that I know that I can do is I can multiply as if they're whole numbers. And you can use any multiplication strategy for whole numbers that you want, okay? You don't have to do with the multiplication strategy I'm using. So what I'm going to do is I'm going to use the standard algorithm because I know that some of you at the end of 5th grade kind of gravitate towards that one. And that's okay, but don't forget that there's other strategies you might want to use in your brain. And what I'm going to do is I'm going to set it up. Now, you've noticed something. You probably noticed that I did not line these up by place value. But when we added and subtracted decimals, I did. So listen carefully, friends. If you are using the standard algorithm for multiplication to multiply decimals, you you don't have to line them up by place value. In addition and subtraction you do, but not in multiplication. So you notice I put the ones place underneath the tens place. That's okay, because right now I'm going to pretend that I'm multiplying whole numbers, okay? So you do it just like a whole number. So 8 times 4 is 32. 8 times 4 is 32. Plus 3 is 35. 8 times 1 is 8. Plus 3, 11. Okay. So where does the decimal go? Well, you see my estimation up here, so you could probably already predict where it's supposed to go so that it's close to 112, because that was what my estimate was. Okay. You might also be thinking, this factor, 144, got 10 times smaller to be 14 4/10. So you know that my product has to get 10 times smaller. Well, I'm going to teach you something else. You are going to go to the factors, okay? And you are going to count how many digits are to the right of the decimals. In this situation, we only have one decimal in our factors, and when I count the digits to the right, there's only one. So I'm going to go to my product, and I am going to make sure there's also one digit to the right of the decimal in my product. Okay, I'm going to do this several different examples. This time I'm going to do 4 just to show you all the situations. So I counted, there's in both factors, there's 1 digit to the right of the decimal. So in my product, there's 1 digit, one digit, I'm going to stick with the word digit, 1 digit to the right of the decimal. It's important though that you knew that your answer should be close to 112. It's a little higher because I rounded down. Okay? But, so we want to kind of put all the things together, but I want to make sure that you understand that this is the last strategy. You can multiply as if they're whole numbers. 144 times 8. Okay? You can count how many digits are to the right of the decimal. So there's 1. And that is how many digits will be to the right of the decimal in your product. Okay? So, let's look at another example. Okay? Just like I was saying, this is one strategy. If you like the understanding, you like the estimating, you like thinking about how much smaller each factor is getting, do that. But I'm giving you another tool and your math tool belt, okay? So this time we're going to be thinking about 5 and 8 tenths, groups of 12 and 2 tenths, okay? Just because I've done so many decimal videos, I'm not giving you story problem context, but you should always be thinking about that. All right, so I'm going to estimate just to show you how this works. I think that 5 and 8 tenths is close to 6. I think 12 and 2 tenths is close to 12. So 6 groups of 12. I'm thinking my answer, my product, should be somewhere close to 72. Okay? All right, so I am going to pretend I have whole numbers. All right? I'm going to pretend that I have 58. And I'm going to pretend that I have 122. All right? And you can use any multiplication strategy. I'm just going to stick with the standard algorithm for right now. When you are multiplying with the standard algorithm, usually we would put the number that has more digits on top. Okay? So what I'm going to do, as you're watching, is I'm going to multiply this out. And what I want you thinking about is what you just learned. How many digits total are to the right of the decimal in both the factors. Okay, so let me rush through this. If you need review on the standard algorithm for multiplication, check out that video too. Okay? And hopefully I didn't make a mistake. If I did, that's okay because we are just thinking about where does the decimal belong. All right, so I know that my answer has to be somewhere close to 72. So you can probably tell because you have this solid understanding of where the decimal goes from the last videos. You probably already know where it goes, that our product is close to 72. You might also already know where it goes because this factor got 10 times smaller and this factor got 10 times smaller, so our product gets 10 times smaller. But my goal is to teach you that last strategy, so let's do it. When I look at this factor, there is 1 digit to the right of the decimal, okay? When I look at this factor, there is 1 digit to the right of the decimal. So that is 1 plus 1, which is 2. So I'm thinking about the total digits to the right of the decimal. And since there's 1 in each factor, the total digits is 2. So how many digits have to be to the right of the decimal? In this situation, 2. So here's 1, here's 2, and that's how I know where my decimal goes. Okay? You also know that my product got 100 times smaller, and you know how the digits shift because we talked about that in a video. But point is, 1 digit, 2 digits to the right of the decimal. So 1 digit, 2 digit to the right of the decimal. And that is how you know where it goes. I want to point out again, you do not have to line them up by place value when you're multiplying. It doesn't have to be tenths on tenths. You're just going to multiply as if they are whole numbers. Okay? Another example, okay? Again. So, next example example is 3 and 25/100 times 1 and 2/10. All right, so I want us making a prediction here. I'm going to count the number of digits to the right of the decimal in both factors before I even get started. 1, 2, 3. So how many digits are going to be to the right of the decimal in my answer? 3. Okay? Same thing every single time. So I'm going to make an estimate. 3 and 25/100. I'm going to round down to 3. I'm going to round this down to 1. So my estimate is 3 because I always want to make sure my answer makes sense. Going to be important for certain situations. So I am going to multiply as if they're whole numbers. Oops. Okay? I want to point something out to you. They are not lined up by place value. Okay? I'm not putting the tens under the tenths. Not in the standard algorithm for multiplication because with decimals, because we're thinking about multiplying them as if they're whole numbers, and that's where you see the place value lined up. You see the ones and ones, tens and tens, hundreds. Okay? So you don't have to do what you were doing with making equivalent decimals when you did addition and subtraction standard algorithm with decimals. I just want to make that clear. Okay? All right. So we're going to multiply. I'm doing it quick because this is not the point of the lesson. I did 2 times 5 is 10, 5, 6. Put my 0, 1 times 5 is 5, 1 times 2 is 2, 1 times 3 is 3, and I add them up. 6 plus 2, 8, 9. All right, so where does the decimal go? Okay, well, I know, and we've been over this, that there's 1 digit, 2 digits to the right of the decimal in one factor, and there's a 3rd digit to the right of the decimal in the other factor. So how many do I need to have? 1, 2, 3 digits to the right of the decimal. Okay, I check my estimate, feels good. Okay, if you wanted to write this as 3 and 9/10, because you know that's an equivalent decimal to 3 and 900 thousandths, you could. But I just want to point out to you one more time that the number of digits to the right of the decimal in the factors combined, 1, 2, 3, is how many digits we'll have to the right of the decimal in the product. 1, 2, 3. Okay? If you did not watch the videos that I was talking about at the beginning, make sure you go back and watch because it's really important to understand what is happening. Okay? Last example. I've been looking forward to doing this example. All right, so we're going to be thinking about 15/100 and 4/10. Okay, so I have 1, 2, 3 digits to the right of the decimal. So in my product, how many digits do I need to the right of the decimal? 1, 2, 3. Okay, I'm going to multiply these like they're whole numbers. Okay, I lined them up as if they were whole numbers, and why am I doing the standard algorithm? That's silly. Okay, this one, the standard algorithm takes much longer. I know. 4 times 10 is 40, 4 times 5 is 20, so my product, when I multiply them like they're whole numbers, is 60. Oh boy, well, we've got a situation because I need 1, 2, 3 digits to the right of my decimal, and I have 1, 2. And that's a bummer, because now we have to do a little more thinking. Actually, that's not a bummer, that's exciting. So why didn't I teach you this trick right from the beginning? Because when you get to situations like this, you really need to think about what's happening so that you can accurately decide what to do. Okay? So I'm thinking that some people might think the answer is this, and some people might think the answer is this. Okay? Because for both of these situations, I just put 3 digits to the right of the decimal. So which one's correct? Well, we're going to have to think about what's going on. Okay? So a couple things we can think about is, how many times smaller did 15 get to make 1500ths? Well, I'm going to say 15 divided by 100. So I know that my product has to get 100 times smaller for this factor. And then I know from 4 to 4/10, my product got 10 times smaller. Okay? So I know that my product has to get 100 times smaller and then 10 times smaller. And you know that if it goes 100 times smaller and then it gets 10 times smaller again, that it's getting 1,000 times smaller. And if you didn't have that understanding just yet, you get to use another strategy that I taught, which is thinking about this like fractions. So let's figure it out. What's the correct answer here? 15 times 4, numerator times numerator, is 60. Denominator times denominator, 100 times 10, is 1,000. So which one of these says 60 thousandths? Which one of these shows that 60 got 1,000 times smaller? Well, let's think about it. So, if I have 60, I'm going to write it over here. And this is something that we learned in the last videos. If it gets 10 times smaller, 60 divided by 10, we know the digits are going to shift one place value to the right. So, 60, the digit 6 goes to the ones place, it got 10 times smaller. Okay? Then I have to make it 10 times smaller again. So my digits are shifting to the right again. So from 60 to 60 hundredths, it's gotten 100 times smaller. To make it 1,000 times smaller, I need to make it 10 times smaller again. So I'm going to have the digits shift one place value to the right again, and we see that it got 10 times smaller, 100 times smaller, 1,000 times smaller. So what is the correct answer? We have 60 thousandths, 0 and 60 thousandths, which is equivalent to what you've written here, and we know that that is not the correct answer. So we have our 3 digits, 1, 2, 3, to the right of the decimal. It's important to note that we did this, all this work, because we had multiplied like they were whole numbers and we got 60. But we did not have 3 digits to place to the right of the decimal. So we had to think about what was actually going on. And that's how we got 0 and 60 thousandths, by thinking about making 60 1,000 times smaller. 100 times smaller for this factor, 10 times smaller for this factor, which made our product 1,000 times smaller than it would be if we were multiplying with whole numbers. Okay? The other thing that I forgot to do was give a little estimate. So if I was rounding and estimating up here, I might have rounded 15 hundredths to 2 tenths. And I might have kept 4 tenths there, how it was. And I might have thought about 2 tenths times 4 tenths, which is 8 hundredths, and known that I rounded up quite a bit here, and that my answer should be a little bit below 8 hundredths, which is the same as 80 thousandths, just so you know. okay? So don't forget that estimating is still something I want you to do every single time. So is 60 thousandths. There's the there's the 3 digits to the right of the decimal, 1, 2, 3. But we also had to use some reasoning there. We couldn't just rely on the trick. And that's why teachers don't teach you the tricks like that, because when you're in these situations, you have to have stuff to rely on to figure it out, okay? So, all of the strategies, you can estimate, okay? Before you calculate, estimate, and figure where the decimal should go based on your estimate, because your answer has to be reasonable, okay? 2, multiply like they're whole numbers and think about how much smaller each factor got. 3, use fractions. You know how to multiply fractions. That helps you, and then you know how to write an equivalent decimal to this fraction, okay? And finally, the last thing that I taught you today is that you can count how many digits are to the right of the decimal in each factor, okay? So if this side of the equation has 1, 2, 3 digits on this side of the equal sign, if they have 3 digits to the right of the decimal, the product will also have 1, 2, 3 digits to the right of the decimal. Okay, so today you can use that little trick to help you. But if Miss Conley sneaks in some problems on your work today, you're going to have to think about where does that decimal really belong so that your answer makes sense. Alright, so you are going to practice at home 3 and 5 tenths times 8, 9 and 12 hundredths times 5 tenths, and 3 and 8 tenths times 4 and 2 tenths. And I'm going to throw another one in there because that's what I like to do. So what if you had 9 hundredths times 4 tenths? And that's going to be like that last situation I went over, where you're going to have to make sense of what's going on. Rely on fractions too to help you. Okay? Bye.